Hello, my name's Clinton, and I'll be your guide through this module of Day 10. We're going to talk about the cosine function, and about how to differentiate the sine and cosine functions. Please don't forget to pause this presentation at any time, if you need a bit more time to think about something. The cosine function is very similar to the sine function, which we have already studied. The graph of the cosine function is actually the same as the graph of the sine function, just shifted to the left pi on 2 units. Here's the graph of cos. Notice how similar it is to the graph of sine. As I mentioned, the only difference is that the graph is shifted by pi on 2. At 0, sine is 0, but cos is 1. And at pi on 2, sine is 1, but cos is 0. The following two properties of the sine graph are immediately true for the cosine graph as well. The graph of cos is always between 1 and minus 1, and the cosine function is also periodic, with period 2 pi. Remember, this just means that the graph repeats itself every 2 pi units. We saw that sine was an odd function. This is no longer true for cos. The cos function satisfies the property that cos of negative x is equal to cos x. That is, the value at x and minus x are the same for any point on the x-axis, as we can see in this diagram here. This means that the graph of cos is symmetric about the y-axis. We could take the graph and flip it around, and it would look the same. Functions with this property are called even. Try these practice questions for yourself to get some practice sketching cosine curves. Use the same method that we used last time to sketch sine curves. Press pause, and when you're ready to continue, press play. Here are the answers. Press pause if you want to look at a graph in more detail. The generic name for the sine and cosine functions is the circular functions, or alternatively, the trigonometric functions. There are a whole lot of important identities involving sine and cos which you should remember. Some of the most important ones are listed here. You can find many more on Wikipedia or on the Maths Learning Center website. Now let's talk about differentiating circular functions. Sine and cos are particularly easy to differentiate. The derivative of sine is just cos, and the derivative of cos is negative sine. It's important to remember the minus sign we introduced when we differentiate cos. Let's look at an example, which uses the chain rule that we studied in Day 9. To find the derivative of 3 sine 2x, we leave the 3 out the front, differentiate the sine, which becomes a cos, and then multiply by the derivative of 2x, which is 2. So the answer is 6 cos 2x. Now here's an example which involves the product rule. To find the derivative of y equals sine x times cos x, we let u equals sine x and v equals cos x. Then the product rule gives that the derivative of y is u times the derivative of v plus v times the derivative of u. Now u is sine x, and the derivative of v is minus sine x. Remember the negative sign. V is cos x, and the derivative of u is also cos x. So the answer is minus sine squared x plus cos squared x. Now pause and try these practice questions for yourself. Press play when you want to continue. Here are the answers.